and welcome to our second episode of Solving NCPhO Problems. This time we're going to be going over the final question from the May test. So, in this question, we have two equal masses of mass m that are put on a spring of equilibrium length L0, spring constant k, in space, so no gravity. Or, well, there is gravity, but it's negligible. They orbit around the spring center of mass at a constant angular velocity omega, and we need to find the new equilibrium distance in terms of these constants and other fundamental constants. So, looking at the answer choices, this problem appears very intimidating at first, but through a technique called dimensional analysis, we can actually make it a lot easier. And this is a technique that helps a lot on physics competitions, especially where the complicated answer choices can make actually like solving it out manually a very time-consuming process in a environment where that's not really an option. So the key piece of dimensional analysis is just working with units, um, and making sure that they all work out. So for this first answer choice, A, we have L0, which has units of meters. We have the mass m, which has units of kilograms. We have omega, which has units of, in our case, effectively just 1/seconds. And then lastly, we have k, our spring constant, which has units of newtons per meter, or what we're going to be using in this case, kilograms per second squared. Okay, so when we plug all of these in, we find that this mw squared term will have units of kilograms over seconds squared. Because, well, we have the kilograms from this mass and then the second squared from the omega, divided by 2k, which is going that 1/2k. So we're just going to flip this. All right, so we can just divide by kilograms over seconds squared, which gives us just 1 or unitless, which matches this one over here. And then given how this L/0 has units of meters, our final thing is going to be meters over 1, which is, well, just meters, which is what we'd want in our answer. So that's a possibility. Then looking at answer choice B, for this one, we can notice how k, right, this k value, it has second squared in its denominator. Meanwhile, mw is just kilograms over seconds. So then that, I guess I should probably label this as A. Then for B, so k minus m omega, that's going to be what's it called? Kilograms per second squared minus kilograms per second. And if you'll notice here, these units don't actually match, which means that we cannot subtract them. And as a result, the answer choice cannot be B. Now let's move on to C. Uh, so in that denominator, we have, let's see, so that's L minus M omega. And if you remember back from B, that M omega term, we should probably fix this, has units of kilograms per second. Meanwhile, L is just meters. So we end up with meters minus kilograms per second, which, similar to B, we cannot do. Because these units don't match, subtraction is not possible, meaning that the answer choice cannot be C. Lastly, looking at D, uh, so D, let's start with that L0 over MK term. So L0 over MK, that's going to equal, or well, that's going to have units of uh, meters from that L0 over over kilogram squared, because we have a kilogram coming from both the K and M. And then over second squared, because once again we still have that K in there. And then from here, we try subtracting this M omega term. M omega, which, whoops, which, as we've seen previously with this one and up here, uh, has units of kilograms per second, which, if you'll notice, does not match these. So once again, we simply cannot do this subtraction. So actually, let me just write out the units of this. So yeah, we can then eliminate D. And as you'll notice, the only answer choice where our units actually worked and were possible was answer choice A, which means that without doing any physics calculations, we're able to determine that our answer is going to be A. And this strategy is very useful on a lot of actual physics competitions, even outside of NCPhO, where whenever you see a question where all the answer choices have these crazy constants and variables in them, usually the first thing you should always do is make sure to check the units, because oftentimes you'll be able to get rid of at least a few answer choices that way. Anyways, thank you for watching, and we'll see you in the next episode. Bye!